We're going to work with word problems today that involve scientific notation. Our objective is I can add, subtract, multiply, and divide numbers written in scientific notation given real-world problems and scenarios. And in math class, the way we handle real-world problems and scenarios is by setting up word problems. We worked on this last week when we were working with word problems that involve multiplication and division of scientific notation. Today we're going to include addition and subtraction word problems. We're using the same strategies as last week. If you'd like to pause the video and read over those strategies, please do. All right, our first strategy is to just read the problem. The mass of the moon is about 7.3 times 10 to the 22nd kilograms. The mass of Earth is 5.9 times 10 to the 24th kilograms. And the mass of Pluto is about 13 sextillion kilograms. I'm not sure I read that number correctly. You might want to double check. Find the combined mass of the moon, Earth, and Pluto. Write your answer in scientific notation. Our next step is to underline or highlight important information. So we're given that the mass of the moon is about 7.3 times 10 to the 22nd kilograms. The mass of Earth is about 5.9 times 10 to the 24th kilograms. The mass of Pluto, I believe that's 13 sextillion kilograms. And they want us to find the combined mass. Combined is a key word of the moon, Earth, and Pluto. And they want our answer written in scientific notation. So a couple of items here. First of all, I say, okay, they want my final answer in scientific notation. I'm going to go ahead and rewrite so that all three masses that are given are in scientific notation. So I'm just going to convert 16 sextillion into scientific notation. We're going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So that's 1.3 times 10 to the 22nd kilograms for the mass of Pluto. Another item I look at, last week we had a lot of multiplication and division word problems. And when you're going to involve multiplication and division, you're always going to have two different quantities you compare. So I'm looking here and I'm comparing kilograms to kilograms to kilograms. Okay, I don't have two different quantities, so I know, okay, this is probably going to be an addition or a subtraction problem. Then I look at this keyword, combined. If we're going to combine the mass, we're going to add up the mass of the moon, Earth, and Pluto. And we're going to write our answer in scientific notation. So I'm going to take the mass of the moon. I'm going to add that to the mass of Earth, and then add that to the mass of Pluto. The mass of the moon, 7.3 times 10 to the 22nd kilograms. The mass of Earth, 5.9 times 10 to the 24th kilograms. And the mass of Pluto is 1.3 times 10 to the 22nd kilograms. There's a strategy that we use when we add or subtract numbers in scientific notation. We know the exponents on our base of 10 must agree. Okay, these don't agree. So then we say, okay, we must make our exponents agree. And what I look at, it's always easier to take the smaller exponent and increase that smaller exponent to match the largest exponent. Our largest exponent is 24. How do I get from 22 to 24? Okay, I add 2. We know left add. That means I'm going to move this decimal point 2 places left and rewrite this number as 0.073 times 10 to the 24th, and it's still measured in kilograms. I have my 5.9 times 10 to the 24th kilograms, and I'm going to add that here. I have to increase this 22 up to 24. How do I increase 22 to 24? I add 2. Again, because we keep using the strategy to increase, we always can go back to our left add. So we're always, with adding and subtracting in scientific notation, going to move that decimal point to the left. How many places? 2 places. 1, 2 places. I need to fill in a 0. 0.013 times 10 to the 24th kilograms. Now that all of my exponents with the base of 10 agree, I just know part of my answer will be times 10 to the 24th. That remains the same. The answer will be in kilograms, and then I just add up. I take my 5.9 plus my 0.073 plus my 0.013, and I'm going to go ahead and add those. You can use your calculator, your tool, if you would like, because I'm not testing whether or not you can add decimals. I'm testing whether or not you can add numbers in scientific notation. So feel free to use your tool. I don't have a tool at home. I'm going to have to work it out longhand. So that's 5.986 times 10 to the 24th kilograms. And that's a huge number. If we move that decimal point 24 places to the right, I believe we would have to fill in 21 additional zeros. That's a huge number. Let's look at another question. I'm just going to read it over. That's our first strategy. On average, Mercury is about 57 million kilometers from the sun, whereas Neptune is about 4.5 times 10 to the 9th kilometers from the sun. What is the difference between Mercury and Neptune's distances from the sun? Write your answer in scientific notation. And at that point, I underline or highlight key items. So we know Mercury is 57 million kilometers from the sun. Neptune is 4.5 times 10 to the 9th kilometers from the sun. Neptune is further than Mercury. What is the difference? Difference is a key word we're going to need between Mercury and Neptune's distances from the sun. Write your answer in scientific notation. So I know my numbers should be put into scientific notation. So what I'm going to do right now is I'm just going to rewrite this in scientific notation. 1, 2, 3, 4, 5, 6, 7. That's 5.7 times 10 to the 7th kilometers. Difference, that keyword tells me I will subtract. Distances, I know I have to end up with a positive number. We don't have negative distances. So even if you're struggling, like, what number would I put first in that subtraction? Well, I have to put the larger number first. So I say, which is larger, 4.5 times 10 to the 9th or 5.7 times 10 to the 7th? We know the larger exponent is the larger number. I need my answer to be positive. I'm talking about distances. So I'm going to go ahead and put the 4.5 times 10 to the 9th first, minus 5.7 times 10 to the 7th second. We're talking about kilometers here. So that keyword of difference told me to subtract. I also know I can pretty much rule out needing to use proportional reasoning, because with proportional reasoning that we talked about last week when we were multiplying and dividing in these word problems, we were comparing two different quantities. Well, here we're just comparing kilometers to kilometers, so I'm like, okay, pretty sure multiplication and division won't go on. I need to search out keywords to decide if it's addition or subtraction. Alrighty, so we're just going to go ahead and subtract these. Again, we know our exponents must agree. Like, okay, they don't agree, so I know I need to increase the smaller number. So I'm going to add 2 to 7 to get to 9. Left add. How many places am I moving left? 2. And if we always use that strategy of increasing the smaller, then there's not several processes that we need to remember. We just need to remember left add. So every time we're going to add on to the smaller number and move our decimal point to the left. So that's 4.5 times 10 to the 9th minus 0.057 times 10 to the 9th. So again, in my final answer, I know I'll have a times 10 to the 9th. I know my final answer will be kilometers. And off to the side, I need to do 4.5 minus 0.057. Please feel free to use your calculator if you need. I am going to borrow from here. Make that a 4. That would become a 9. That would become a 10. So I get 3. 9 minus 5 is 4. Bring down that 4. I should have never crossed out that one. Bring down my decimal point because I've lined them up. So it's 4.443 times 10 to the 9th kilometers. Please make sure at any point, if you need the video paused, you just raise your hand. I'm sure the substitute is pausing it several times throughout, but if you find I'm going a little bit too fast, raise your hand. The substitute will pause the video for you. So we should have gotten 4.443 times 10 to the 9th kilometers. That's how much further Neptune is than Mercury from the sun. Question 3. According to a 2010 census, there were 6.1 times 10 to the third people living in Duanesburg, New York, and 20,600 people living in Rotterdam, New York. How many more people live in Rotterdam than Duanesburg? Write your answer in scientific notation. Okay, so I actually read the problem and underlined key facts all at once this time. First of all, I noticed I'm comparing people to people, so good chance I don't want to set up any sort of a ratio proportional reasoning. It says, okay, we're either adding or subtracting here because we're comparing the same quantity, people to people. I know my answer's got to be positive. You can't have a negative number of people, so I know my larger number will come first. And I want to know how many more people live in Rotterdam than Duanesburg. There must be more people living in Rotterdam. How many more? We'll find out how many more by subtracting. So those key words tell us to subtract. I want my final answer in scientific notation, so I'm going to make sure both of my numbers are written in scientific notation. 1, 2, 3, 4. 2.06 times 10 to the fourth. People live in Rotterdam. Yes, that is my larger number. 4 is greater than 3. So I'll just take the number of people living in Rotterdam, subtract off the number of people who live in Duanesburg, and I'll find out how many more people live in Rotterdam than Duanesburg. So I'm going to take 2.06 times 10 to the fourth minus 6.1 times 10 to the third. We're talking about people. Again, I focus in on my exponents. I say, okay, I need to increase 3 by 1 to get to 4. Left add. That's why I always tell you to increase, because that way we have one process to remember. You're increasing, so we're moving our decimal point to the left, this time one place to the left. So we have 2.06 times 10 to the fourth minus 0.61 times 10 to the fourth. Talking about people. 10 to the fourth, 10 to the fourth, so I know my final answer will involve a 10 to the fourth. And I know my final unit will be people. Now I have to take 2.06 minus 0.61. 6 minus 1 is 5. 10 minus 6 is 4. 1.45. So there's 1.45 times 10 to the fourth more people living in Rotterdam than Duanesburg. On this one, I mean, when you're talking about people, it might be better, although they want our answer in scientific notation, so I worked it out in scientific notation, it might be better to deal with this in standard form. So this right here, 6.1 times 10 to the third, 1, 2, 3 places, fill in 2 zeros, so that's 6,100 people live in Duanesburg. We have 20,600 people living in Rotterdam. We're going to go ahead and subtract those off. 0, 0, 6 minus 1 is 5. 10 minus 6 is 4. So there should be 14,500 more people living in Rotterdam than Duanesburg. A lot of times, if you're talking about number of people, it's just easier to look at it in standard form. It just makes more sense to us. Let me just check that 1.45 times 10 to the fourth is really 14,500. So if I take 1.45, move my decimal point 1, 2, 3, 4 places, then I have 14,500 people. I just wanted to double check that's just a nice quick double check. First of all, if we work it out in standard form, does that match what we worked out in scientific notation? Sure enough, it does. Either way, we get 14,500 people, and that seems reasonable. Rotterdam is quite a bit larger than Duanesburg. What I'm going to do right now is I'm going to stop the video. I'm going to produce a second video dealing with the last 3-word problems. So take a minute, regroup, make sure you have all your information down, and you can even start trying question 4, and then come back to the next video and I'll work it out with you.